data is there, 1 TB disk filled, still data is there, that is called as big data, right? So your disk is filled, okay, maybe after 1 year or 2 years disk is filled, still data is there. So data is that more than that, right? So data is more than, so data is more than capacity. So more than capacity, that is called big data. You facing big data problem, okay? Yes, your disk capacity is only 1 TB, but data, yes, maybe your data, say like recordings, maybe your class recordings, okay, maybe your personal, maybe function videos and all this data full. Yes, 1 TB disk is filled, right? Still data is there. 1 TB disk is filled, still data is there. 1 TB disk is filled, still data is there. Means you facing big data problem. Okay, right? So this is your computer, right? So you facing big data problem. Suppose some company hard disk. Yes, the disk, that company storage server. This is database server. Database server capacity is 100 TB, but data is more than this 100 TB. This 100 TB disk is filled. 100 TB disk is filled. Still data is there. Data is more than 100 TB. Suppose, for example, here, suppose, yes, suppose company started in 2015. For example, company start in 2015. Yes, initial capacity is 100 TB. So initial capacity 100 TB. So the company started in 2015. Initial capacity, yes, 100 TB, right? Suppose here for the first year generate some data. Next 2016, next year some more data. Next 2017, some more data. 2018, some more data. Next 2019, next another data. 2020. Suppose in 2020 here some disk is filled. This 100 TB filled. Still data is there. Still data is there. Still data getting correct. 100 disk is filled. 100 TB disk is filled, right? This 100 TB server filled. Completed. 100 TB server filled. Yes, still data generating means you now facing big data problem. The company facing big data problem. Okay, the company facing now big data problem, right? Clear? So you can, so 100 TB capacity is only 100 TB, but incoming data is lot of data generating here. The data is more than 100 TB, right? So that kind of data is called as big data. Okay, still data getting, that is called as big data. So what's the definition of big data here? So any amount of data, any amount of data, any amount of data which is beyond of storage limit, which is beyond of storage limit, storage limit, beyond of storage limit called as big data here. Storage limit called as big data. So any amount of data which is beyond of storage limit is called as, yes, is called, yes, is called as big data. That's it. It's called as big data. Simple. So this is big data definition. Any amount of data which is beyond of storage limit called as big data. So this is big data definition. Best example, your computer. Yes, your computer capacity, your computer disk capacity is only 1 TB. Still data is there. Yes, unable to store data. So this 1 TB disk is filled, that volume filled, right? Still, yes, some data is there, right? Means you facing big data problem. Just you facing big data problem. So whatever data generating, yes, your personal data. So whatever personal data generating, that is beyond of your storage limit, right? Beyond of your computer storage limit. So beyond of your computer storage limit, that is called as big data. So you facing big data problem like that. Companies also facing big data problems. Okay, that incoming data is more than the capacity of servers, facing big data problems. So that is called as big data. So any amount of data which is beyond of storage limit is called as big data. So this is simply big data definition. You can define like this, simple definition like this. Okay, right? Yes, big data examples. Yesterday we have discussed about many number of examples like historical data examples, historical data, stock exchange data, black box data, social network sites, medical data, next online shopping, transport data, like this many examples discussed yesterday. Okay, okay, fine. Now here, so with big data there are some lot of challenges. So what are the challenges facing big data? Let us have big data challenge. Today's topic is big data challenges. Big data challenges. So what are the challenges of big data? Big data challenges. So what are the challenges that facing from the big data? Big data challenges. So big data challenges. First one is data storage. Data storage. First one data storage. So second one, yes, data processing. Data processing. Second one data processing. Data storage, data processing. Okay, right? Data storage with big data. Yes, data storage problem here. Yes, next data processing problem here. Okay. Yes, of data processing here. Next high-end hardware requires with big data. High-end hardware requires. High-end hardware. High-end hardware requires. Okay, right? Next, there is a chance of yes generating very large files. Sometimes generating very large files. So very large files. Very large files here. Next backup. Backup. Backup and recovery. Backup and recovery. Backup and recovery. Backup and recovery here. Next disaster management. Disaster. Yes, disaster management. So these are the big data challenges. Yes, they are the main challenges here. Apart from the other challenges we'll discuss later here. These are the main challenges of big data here. So these are the primary challenges, main challenges. We have many things. These are the main challenges. Apart from this, we have other challenges. Other challenges we'll discuss next. Okay, 1 second. Yes. So big data challenge. First of all, about data storage. What is data storage? What is this challenge? Let us see about this challenge. Data storage challenge. Okay, data storage. See about data storage. Okay, data storage. See data storage. Traditional systems versus Hadoop. Now let us see that. Traditional system. How data storing traditional systems. How data storing in Hadoop. Traditional systems. Just every topic. All these challenges. We'll see. Traditional systems versus Hadoop here. So data storage, traditional, yes, so traditional systems versus Hadoop. Traditional systems versus Hadoop. Let us see this one here. Traditional systems. First about traditional systems. Traditional systems. See traditional systems like maybe Oracle database, maybe MySQL database, something like this. See traditional systems architecture. Let me explain about architecture. In traditional systems, let us take traditional app. Traditional app. Yes, maybe Facebook app or Flipkart app or maybe Amazon, any application. Let us take that application here. Okay, what is happening here in application? Suppose Facebook. Let us take Facebook here. In Facebook, suppose your mobile. Okay, from mobile uploading some data. So this is your browser, right? Your browser mobile. Let us say this is browser. So just your browser mobile. Okay. Yes, in your mobile this is a browser, right? Yes, this is browser. Just browser. Browser in your mobile, right? So browser. From this uploading data, right? When you're uploading data, what happens here? When you're uploading data here, yeah, the data goes to Facebook application. Here it's a application app. The app. Okay, app, right? Yes, maybe Facebook or Flipkart. Okay, whatever it is here. Maybe Facebook application or Flipkart application, maybe Amazon, something, some app. So first of all, browser data. So simply here browser data. So browser data goes to app, right? So app taking data here. After taking data here, so simply yeah, the storing database. Storing the database, right? Just database. Storing database. So the database, right? Storing database, right? The data storing database. So this is traditional application, traditional systems here. So this is client type, this is client type, this is application type. Yes, application, it's application type. So this is application type. Next, this is database type. So next is database server. It's a database, right? It's a three-tier architecture. It's a database, right? So client type, application type, database type. So client, the browser, it's a client. It's a client. This application, next database. It's a three-tier architecture. Three-tier. It's a traditional system is a three-tier. So this is client tier. This is called as client tier here. Okay, let me write here. So this is client. So client. So this is client tier. Okay, right? TAER. Client type. Next, this is application type. This is application type. So this is application type. Application type. Next, this is database type here. So database type. Okay, tier is nothing but layer, just layer of communication. Okay, yes, it's a three-layer communication, right? So browser, application, and database. application database like this, right? Okay, this is traditional system. What is happening traditional system? Okay, this is a browser, application, and database. Okay, yes, in traditional database server, data getting database server. Suppose initially database server capacity, let us say some 100 TB capacity, 100 or 10 TB. Yes, so 1 minute initially database setup is 10 TB. Suppose 10 TB filled, then increasing volume of this. Yes, second field data storage. See this. Yes, our topic is data storage. Data storage. Data storage in traditional systems. Data storage in traditional systems. Our topic is data storage in traditional systems. In traditional systems here, data storage. Here this database, backend database, right? In database storing data. Suppose initial capacity, let us say 10 TB disk. 10 TB this is. So disk is filled. Then increasing volume of this is. Increasing volume. Increasing volume. So this also filled again, increasing volume. Yes, second increasing volume like this. So once disk filled here, the DBA database administrator will increase the volume of disk here. The storage space, increasing storage space, just increasing storage space, just increasing storage space like this, just increasing storage space, just simply increasing storage space, right? So initially 10 TB disk. Okay, once 10 TB disk here, yes, next one more 2 TB adding, next 2 TB, continuously adding 2 TB, 2 TB, 2 TB like this. So that increasing volume of disk, right? Just increasing volume of disk. This is called as vertical scaling. Increasing volume of disk, it's a vertical scaling. Okay, yes, in traditional system, how the DBA will increase the value of disk? Let us see. Yes, that storage, how the DBA will maintain this, will manage this disk space. Okay, initially some disk capacity. So how to increase capacity of disk? Next increasing like this continuously increasing capacity of disk, right? So how traditional the DBA, how the DBA will manage that? Let us see that. Traditional system, the storage management. Yeah, data storage in traditional system, data storage management. Topic is traditional system, data storage management. After finishing, we'll go to Hadoop. Hadoop data storage. We'll see next data storage in Hadoop. Now data storage in traditional system. Same system here. So initially it's some disk. So this is continuously increasing disk, right? How we can increase the disk capacity? So what is yes, how that DBA, how that DBA will increase the volume of disk? Let us see that. Okay, the DBA activity. Yes, I have seen all this practically here. I worked practically. DBA activity. Okay, what is DBA activity? See, initially your computer, see this, your computer. Yes, in computer, there is a motherboard, right? In computer, there is a motherboard. So this there is a motherboard. There is a motherboard. So this motherboard contains by default 12 LANs, 12 LANs or slots, anyone you can say. 12 slots. There are 12 slots. Motherboard contains 12 slots. Okay. Yes, each slot with 2 TB, with 2 TB disk, 2 TB disk. Initially 2 TB disk. Okay, initially each slot with 2 TB disk. Suppose initially first database setup, initial setup with only 2 TB. Initial setup with only 2 TB disk. Initially only 2 TB disk. Okay, initial setup with only, assume that initial setup with only 2 TB disk. Right, okay. So now database capacity only 2 TB. Suppose 2 TB disk is filled. Okay. So once 2 TB disk, 2 TB disk filled. Now what happens here? So once reaching 90% of storage space, 90% is received here, 90% of storage space reached here, then DBA will get the alert message. Okay, critical message here, 95, yes, 80% is warning here, 90% critical message. On receiving critical message here, disk filled, critical message. On receiving this, we will add one more disk. So once 2 TB disk filled here, okay, the DBA will add one more disk. So one more disk to motherboard, right? Adding one more disk to motherboard. Okay. So motherboard, right? How many slots totally? 12 slots. There are 12 slots, right? So initially first slot 2 TB disk, 2 TB disk added. Second, so first slot over, right? So first one completed. second one completed. Okay, first slot completed. Okay, so 1 second. First slot or first lines, anyone you can say first slot with QTB, right? QTB completed. So this key field. Then using second slot with QTB. So this also filled. Yes, then using third slot. Yes, QTB. Next, this also filled. Fourth slot with QTB up to 12 slots. 12th slot. So 12th slot. So finally 12th slot with yes QTB, right? Like this QTB, TTB adding like this. Just adding QTB like this. So finally, what is final volume here? How much volume here? Finally, how much volume? Yes, how much volume here finally here? Yes, anyone? Yes, how much volume here finally here? How much volume of disk? So how much volume? Finally, how much volume is it? 2040, right? It's a 2040B. So reach to 2040B. Fine, well and good. Okay, thank you for your response. Okay, 2040B. So you get 12 slots. Each slot with 2 TB adding like this, right? 2040B. So you can, yes, max capacity is for 2040B, right? Next step. So this is the minimum system care 24 TB disk up to 24 minimum. It's a minimum. Suppose if it is high-end hardware, yes, high-end. If it is high-end here, yes, high-end system, high-end computer, yes, a motherboard, yes, a motherboard, yes, in high-end system, a motherboard can have 24 slots. Motherboard 24 slots. Okay, high-end system motherboard with 24 slots. If it is 24 slots, then what's the capacity here? Then what's the capacity? What's maximum capacity? That case, max capacity. So max capacity. So what is max capacity in that case? 24 multiplied by 2 TB disk, right? So this equal to how much is a 48 TB, right? 48 TB. Yes, you can make it up to 40 TB, right? So the max capacity. High-end system. If it is high-end system, yes, high-end system motherboard can have 24 slots. 24 slots here. Maximum capacity is 24 into 2 TB. It's a 48 TB, right? So increasing to 48 TB. Okay, this is a 48 TB, right? Now it's a 48 TB. Yes, 24 slots. Yes, here every computer, for every computer 12, that is default. Every computer by default 12 disks we can add it. Okay, high-end system can have, yes, 24 slots. Okay, so 24 high-end system motherboard can have 24 slots. That case 24 multiplied 2 TB. So this is equal to 48, right? Okay, next. So this high-end system, so very high-end system, very high-end system, yes, can have two motherboards, two motherboards, two motherboards. Very high-end system can have two motherboards. Yes, if it is two motherboards into 24 slots, right? 24 slots is equal to 48 slots, right? So getting 48 slots. 48 slots multiplied by 2 TB. Yes, this value is equal to how much here? 96 TB. This is still very high-end system. Okay, very high-end system, right? So 96 TB. Very high-end system is 96 TB, right? 96 TB here. Next, one more thing here. Yes, 2 TB disk. Just we are using 2 TB disk, right? 2 TB disk. So every time adding 2 TB disk, right? 2 TB disk. Just adding 2 TB disk every time. Just adding 2 TB disk every time, right? Every time. Yes. In market, 10 TB disk also available. 10 TB disk also available in the market. 10 TB disk also available. So 10 TB disk also available. Not only 2 TB, 10 TB disk also available. Yes, in market 10 TB disk also available. Yes, if it is 10 TB disk, what happens here? 10 TB disk, then 48 slots multiplied by 10 TB is equal to how much here? 480 TB. This is very high-end system in the market here. Yes, very high-end here. Okay. Yes, about disk I'll tell you. So SSD or HDD, what is the disk? I'll tell you. Okay. In production environment using RAID disk. It's a RAID disk. What is RAID disk? I'll tell you. RAID disk, using RAID disk. Okay. Yes. So 48 slots into 10 TB, it's a 480 TB, right? It's a 480 TB. So maximum capacity what 480 TB. So the server capacity maximum we can make it up to 480, right? Yes, 480 is not recommended. If it is 480 here, automatically speed performance reduces. That impact on performance. Okay, in that case we need dual core processor, dual core required here. Even dual core, it's not easy to handle 480 TB here. Okay, 480 TB is not recommended. Just recommended this one 96 is recommended. Okay, for better performance 48 is enough here. 48 is a yes, this is basic capacity, right? Yes, recommended 96 up to 96 is recommended. This area recommended up to 96 means around 100 TB, around 100 TB, right? Same thing started, right? 100 TB, 100 TB. So 100 TB that is recommended. Okay, 100 TB recommended, right? Okay, yes, here. So what is storage? In storage here, in storage what happened here? Yes, if disk filled just increasing, suppose initially capacity maybe 10 TB, next adding 2 TB, 2 TB, 2 TB like this 2 TB, 2 TB like this adding, right? So max is up to 100 TB, 96 TB, right? Just increasing volume of disk. So increasing volume of disk, this is called as vertical scaling. Okay, in traditional systems follows vertical scaling. So traditional, yes, traditional traditional databases, traditional databases like Oracle database, Oracle database or MySQL database or Microsoft SQL Server or DB2. These things follows yes vertical scaling. So what is vertical scaling? Just increasing volume of server, increasing capacity service vertical scaling. So following vertical scaling. So all the traditional systems follows vertical scaling concepts. So vertical scaling, right? So what is vertical scaling here? Now question is what is vertical scaling? Okay, these are the interpretations for Hadoop storage. Okay, see, even Hadoop developer, you must have the hardware knowledge also, that admin knowledge also. At least 50% of Hadoop administration, you must have that. Storage knowledge. Without storage knowledge, how can you work on Hadoop? Yes, when you're working on Hadoop here, you must have the storage knowledge, how this data is storing here, how Hadoop is behaving, depends on storage. You must have that knowledge here. Okay. Suppose Java developer, for Java why storage knowledge nothing is required. How that application is working enough is Java developer, .NET developers. But when come to Hadoop, Hadoop is always related to big data processing, storage, right? Okay, so that case, so Hadoop developer must have this information. Otherwise, no use. Just only working on Hadoop application, what is use? No, yes, you have to understand that backend system also. How backend is there? How the storage? You must have that knowledge. Okay. Now, question is what is vertical scaling? So, what is vertical scaling? See, in document, main document, everything prepared. In main document, already share, yes, I'll share. Already shared the main document here. Yes, any pending persons are there, for them, I'll share it. Okay, some new guys are there, for them, I'll share it. Vertical scaling. So, what is vertical scaling? So, vertical scaling is increasing, just increasing capacity of servers, increasing, yes, increasing capacity, just increasing capacity of server. So vertical scaling is increasing capacity of server. Capacity of server is a vertical scaling. Okay, vertical scaling, right? Increasing capacity, so you say increasing capacity of server, it's a vertical scaling, right? Next, Hadoop follows horizontal scaling. What is horizontal scaling? We'll discuss. Okay, what is horizontal scaling? We'll discuss. Just wait. So it's a yes, increasing capacity. Yes, just it is increasing capacity of server. Or just increasing capacity of server. Right? Okay. That is vertical scaling. Yes. Our notes, that is Hadoop. That is horizontal scaling. Yes, we'll discuss. Next topic is that only here. Okay. So this is right. So this is traditional system. What is traditional system following here? Storage, right? Now Hadoop. Yes, what is Hadoop here? Yes, let us see Hadoop. Same storage in Hadoop. Data storage in Hadoop here. Okay. Yes. So what is big data problem? The main problem is data storage problem, right? So data storage problem. Data storage. Just increasing volume of disk, right? So max is 100 TB. Suppose 100 TB is filled. That case. That case it fails, right? 100 TB once 100 TB filled database will store next coming data cannot. Okay, so there is a limit for this. Limitation for this relational systems. So beyond of 100 TB we can't store data. So failing, right? Now this is big storage problem. First storage for big data storage problem. For this, Hadoop provides best solution. How Hadoop provides best solution? What is solution from the Hadoop? Let us see Hadoop solution for the storage. Okay, Hadoop storage. Let us see Hadoop storage. So what is solution from the Hadoop? Let us see about Hadoop here. Yes, Hadoop. Hadoop is a master and slave architecture. Yes, Hadoop. Hadoop is a master. Hadoop is a master. Yes, master and slave architecture. Master and slave architecture. Master and slave architecture. Master and slave architecture. Yes, we'll see what is master and slave architecture. Okay. Yes, there are some nodes in Hadoop like name node, data node, secondary name node, job tracker, task tracker. So these things. Those nodes later we'll discuss. What is job tracker? What is name node? Those things we'll discuss. Before that, yes, to understand this one here, I'll explain simple architecture. Hadoop. Yes. Yes, Hadoop is a master and slave architecture. Master and slave architecture. Let us see. What is master and slave architecture? Master and slave architecture. See, it's like this. Yes. So master, it's a name node. Name node is a master. Name node. So this is high level architecture. Low level we'll discuss next. So name node. So this is master. So name node, it's a master. So this is master. So this is master. So actually master is others also. Those next. So name node is a master. It's a master. Just it's a master name node. It's a master care. Next slave. Next slave node. Slave node. Yes, slave node. Yes, here slave node. Yes, slave one, slave one. Like this, multiple slave nodes. Yes, slave nodes. So on slave node, there is a data node. There is a data node. Data node one. Data node one. Data node two. Yes, in shortcut we can write data node one, data node two. Next data node three, data node four. Yes, apart from data node, there is a task tracker also. The topic we'll discuss next. Wait, I'll tell you next. Yes, about data. Yes, data center we'll discuss now. Yes, this topic is same data center topic only here. We'll discuss. Wait. Yeah, this is master. So this is master. These are the slave nodes. Data node one, data node two, data node yes three. Okay, data node four, data node five. Yes, data node six. Okay, like this, all these number of data nodes. Multiple data nodes. Okay. So data node n number of data nodes. Okay, data node n number of data nodes. Yes, n number of data nodes. Many data nodes like this. So like this, multiple data nodes. Data node n number of data nodes. Okay, right? So data node 6 up to n number of data nodes. See, here every data node communicates with name node. Here every data node communicates with name node. Just communicating name node. Yes, internal architecture next we'll discuss. Wait, topic is there. This is it. Yes, simply high level architecture. Just high level architecture. This is all these data nodes. Every data node communicates with name nodes. Communicating. Yeah, this layer is a slave. This is called a slave here. So master and slave. So this is slave. This whole thing is slave. This whole thing is called a slave here. So this is slave. This whole thing is this is called a slave here. So this is master and slave. It's a master and slave architecture. This is slave. This whole thing is called a slave signature. This master and slave. Slave nodes. So what is purpose of slave node? To store data. Master nodes. Yes, every request taken by the master node. Master node is responsible to take your request. Every request taken by the master node. Okay. Yes, master and slave. What is master? What is slave here? Master is like a manager. Slave is like a employee. Manager and employee. See, manager giving instruction to the employee, right? Employee is working as per the instructions from the manager, right? So manager and employee. So master is like a manager here. So next slave is like a employee. So here master name node give the instruction to data node. Now data node has to work as per the instructions from the name node. Okay. Now here client request. Every client request goes to name node. Client request. So client. Yes, client request. So client request. Simply client request. Client request always goes to name node. Always client request goes to name node. So what is client request? There are two things. First one is data loading request. Data plus data loading request. Data loading request or job submission, or either data loading or job submission. Either data loading or job submission. So first let us see data loading, because our topic is data storage, right? Data storage topic. So topic is storage. Data storage, right? Data storage. First we'll see data storage, next data processing we'll see here. So either data storage or job submission. So job submission is nothing but data processing, not data loading, nothing but data storage. Okay, 1 second. Yes, this is crystal system. This is actually Hadoop. That internal architecture is the internal architecture. Yeah, this topic will discuss. After finishing this, next I'll go to this one. Internal. See, name node is like this. Name node, second name node, job tracker. This is master. Next, they are the slaves. Yes, we'll discuss. Let me finish first high level. After that high level, I'll go to low level. Okay. So this is a client. From the client, request is job submission or data loading. There are two things from the client: data loading request and job submission request. Either data loading or see data loading request. One is data loading request. Okay, next job submission. Data loading request simply goes to name node. Here this is job submission. That request goes to some job tracker. See job tracker, name node, second name, they are master. So these all these three called as master. Now these are the slave nodes. In slave nodes, there is a data node and task tracker. Yeah, this is low level architecture. We'll discuss next. Before going to this, first we'll see high level. So once you understand high level, you can understand low level. First, let us see high level. Yes. Yeah, adding volume, it's a yes, vertical scaling. Adding volume to this is a vertical scaling. Okay. Yes, I'll clear every topic very clearly. I'll explain it. Okay. Yes. So Hadoop, it's a master and slave architecture. First, data loading request. So data loading request here. Yes, how that data storage takes place. How data storage in the Hadoop. See, if it's a traditional system, only one system. Yes, our data get generating continuously here, increasing volume of these traditional is very simple here. So data getting just increasing volume of disk, right? Just increasing only one system, easy to manage. It's very simple. Okay, right? Now come to Hadoop here. When come to Hadoop here, what is happening here? Data storage in multiple servers, not single server. Data storage on multiple servers. Data storage on multiple servers, not single server. Data storage always in multiple servers. Servers maybe 100 servers or 200 servers. Depends on data. Depends on data using number of servers. Okay. Now let us say same topic we'll discuss now. How data storage takes place in Hadoop here. So let us see loading data. Suppose loading data, loading a file. For example, loading a file yes with 100 GB. Loading a file with 100 GB. Okay, how this data storage takes place? 100 GB file. Loading a file with 100 GB capacity, 100 GB. Size of the file is 100 GB here. So how this data storage takes place? 100 GB. What happens here? Yes, here Hadoop. See, storage purpose is the HDFS. Hadoop. There are two core modules in Hadoop here. Now Hadoop, there are two core modules. There are two core modules. Two core modules in Hadoop. So first one is HDFS. Second one is MapReduce. HDFS MapReduce. So what is HDFS? What is MapReduce here? HDFS. Yes, it's a file system. HDFS is a file system. File system to store data. The storage, data storage. To store data. Okay, HDFS is a file system to store data. What is MapReduce? So there are Java programs to process data. Okay, so HDFS it's a file system to store data. So MapReduce, there is Java programs to process data. Okay, right? So HDFS. So this is like a backend, to store data here, So Java programs, MapReduce Java programs. So this is like a front end here. So these are like a front end to process data, like a front end. So front end, right? Like a front end. So front end, back end, right? So front end, back end. Okay. So front end, back end, right? So HDFS behaves like a back end. MapReduce like a front end here. So front end, back end. Here it's a front end, back end. So first here MapReduce later we'll discuss. Now our topic is storage. So now let us see HDFS. So what is HDFS here? HDFS means Hadoop. Yes, Hadoop distributed system. Hadoop distributed file system. One second. Hadoop distributed file system. So HDFS stands for Hadoop distributed file system. HDFS stands for Hadoop distributed file system. So what is distributed file system? Now question is here, what is DFS? What is DFS? So what is DFS? Let us see that. Yes. So before going to DFS here, first let us see about traditional systems. What are traditional systems? Traditional file system. Okay. Yes. HDFS. So what is DFS? Before going to DFS here, first traditional Linux file system and Windows file system. After that we'll go to DFS. Okay. The traditional, yes, traditional file systems. Okay. So what is DFS? Next, what is traditional file system? What is the difference between these two here? What is DFS? Then what is traditional file system? Okay. Now let us see traditional file systems. So first about traditional file systems. Yes, so traditional file systems are Linux and Windows. Linux and Windows. They are the traditional file systems. Linux file system, Windows file system. Linux and Windows file system, right? So traditional file systems are Linux and Windows file systems. Linux, Windows file systems. Yes, in case of Linux, Windows file system. Yes, I think already you have some idea about this. Windows file system is a NTFS. Okay, Linux file system is a ext2 old version, next ext3, latest is ext4. Linux file system is ext4. Okay, now currently Linux file system is ext4. Okay, so Windows file system is NTFS, networking technology file system. Okay, so NTFS. So Windows is NTFS. Okay, Linux file system is ext4 file system. Okay, yes, see this as per traditional file systems. Okay, as per this traditional file system, size of each block equal to 4 KB. Okay, as per traditional file systems here, yes, 1 second. As per traditional file systems, yes, one file storing on only one system. One file storing on only one system, not multiple systems. Yes, one file storing on only one file system. One file storing on only one file system. Next, what is DFS? Let us come to DFS. What is DFS? So DFS means distributed file system. DFS means distributed file system. DFS stands for distributed. Yes, distributed file system. Distributed file system. So as for the distributed file system, storing one file system. Now one file is only one computer. One system means one computer. One file storing on only one computer. One computer, not multiple computers. Okay, one storing on only one computer. Okay, only one system means one computer. Yes, in DFS. Okay, so as per yes, in DFS, in distributed file system, in DFS, one file divides into multiple parts. One file divides into multiple parts. One file divides into multiple parts and distributing onto multiple computers in the network and distributed. That is DFS distributed file system name itself. Distributed file system name itself. Okay, so name itself. So file distributing onto multiple here. So here in DFS, one file divides into multiple parts and distributed onto yes multiple. So distribute onto multiple computers or multiple systems in a network. That means one file storing on multiple computers. Okay, suppose 10 GB file dividing into multiple parts storing on multiple computers, not single computer. Okay, yes, if we traditional system here one file is only one computer, not multiple computers. That facility is not available. That is not architecture. Architecture is different here. When come to DFS architecture, one file splitting into multiple, one file divides into multiple parts and distributed onto multiple systems in network. That is DFS concept. Okay, DFS concept, right? Okay, yes, now come to HDFS. In HDFS, what happens here? Hadoop distributed file system. Hadoop, yes, Hadoop distributed file system. Yes, in HDFS here, what happens? In HDFS, okay, a file divides into multiple blocks. A file divides into yes multiple blocks. A file divides into multiple blocks and distribute onto multiple nodes in the cluster. Yes, Hadoop network called as Hadoop cluster. Hadoop network, it's a Hadoop cluster. Okay, yes. In HDFS here, a file divides into multiple blocks and distributed onto multiple nodes in cluster. Yes, who will that? Name node. Name node will do that. We'll discuss that. In HDFS, a file divides into multiple blocks and distribute onto multiple nodes in a cluster. Hadoop network is called as Hadoop cluster. Exactly what is cluster? I'll explain. Just a minute. I'll explain. Yes, in HDFS, a file divides into multiple blocks and distributed onto multiple nodes in cluster. Right, okay. Now block. What is block? Now question is here. What is block? So what is block? So question is now what is block now? Now here question. What is block? See, in any file system, take any file system like Linux or Windows or HDFS. Take any file system. So take any file system here. Any file system. like Linux file system, Linux file system, or HDFS. In any file system, hard disk, hard disk, hard disk divides, hard disk divides, hard disk divides into multiple blocks. Hard disk divides into multiple blocks. Just divides into multiple blocks. Okay. So in any file system, maybe like Linux or Windows or HDFS, any file system, hard disk divides into multiple blocks. So what is block? Okay. See, hard disk. Let us take hard disk here. Suppose this is hard disk. This is hard disk multiple blocks. So this is block one. Block one. Okay. So block one. Yes. Next block two like this. Block one. Yes. Block two. Block one. Block two. Yes. Next block three. So next is block three. Yes. Next block four. Yes. Next block five. Next block six like this. Multiple. Yes, number of blocks. Block n. Here this is a block n, right? Here this number of blocks depends on size of disk and file system. Depends on file system number of blocks changing here. Number of blocks depends on file system and disk. Okay. See number of blocks. Number of blocks depends. Number of blocks depends on storage. Depends on volume of disk. Depends on volume. Depends on volume of disk. Volume of disk and file system. And file system. Okay, volume of disk and file system. Okay, first let us say about file system here. Yes, traditional file system. Linux Windows. In Linux Windows file system here, size of each block is equal to 4 KB. Okay, so as per Linux and Windows. So as per Linux Windows, as per Linux and Windows, Linux and Windows file system here. Linux and Windows file system. Yes, file system size of each block. Size of each block. Size of each block is equal to size of each block is equal to 4 KB. Just only 4 KB. As per Linux, Windows file system size of each block is equal to 4 KB. As per Linux and Windows file system size of each block is 4 KB. Okay, come to Hadoop. As per HDFS. As per HDFS. In HDFS, yes, Hadoop distributed file system. In HDFS, the size of each block depends on version. Size of each block depends on version. Depends on version. Hadoop version depends on Hadoop version. Hadoop version. Let us see all that here. Hadoop versions depends on Hadoop versions. Okay, size of each block depends on Hadoop versions. So first Hadoop 1.x version. Yes, it was released in 2009, means 11 years back. First version of Hadoop released in year 2009. So in 1.x version 1.1, 1.2 like this. So 1.x version here. Yes, size of yes, that's a default size of each block. Default size of each block is 64 MB. It's a 64 MB. It's a 64 MB. So default size of each block. Yes, each block equal to 64 MB. Yes, in 1.1.x version here, default size of each block equal to 64 MB. Okay. Yes, we can change it. Yes, it can be configured. Yes, it can be configured. Means we can change it here. It can be configured up to 128 MB here. We can make it 128 MB. How to configure we'll discuss. In Hadoop setup we'll discuss. Okay, how to configure. After finishing setup, we have separate topic and Hadoop configurations. That time we'll say how to increase that block size, increasing block size. The topic we'll discuss next. Okay, so it can be configured up to 128 MB. So this is a case of Hadoop 1.x version. Okay, next second version of Hadoop 2.x or 3.x. 3.x recently released here. No one using. Okay, no one using here. Currently, yes, industry using second version of Hadoop 2.7.2. Yes, most of the companies using 2.7.2. Yes, even our projects also we are using 2.7.2. See, our first two projects are 1.x version. Yes, I had the good experience with 1.x version. First two projects on 1.x version here. Next third project on second version here. Next, fourth project is Spark framework. That is also using Hadoop 2.7, 2.7.2. Yes, here first two projects are Hadoop 100x version. Second Hadoop project is second version here. So third project on second version. Now currently fourth project, recently completed fourth project. That fourth project using Spark framework, with Hadoop second version. Spark is engine. For Spark engine basic platform is again Hadoop. Again Hadoop request. Spark is running at top of Hadoop. Okay. So here as per second version or third version of Hadoop, here default size of each block is 128, means double 128 MB. Yes, it can be configured up to 256 MB. Yes, we can make it up to 256 MB here. Okay, it can be configured up to 256 MB. Yes, this is so this is default 1.x version and 2.x version. Size of each block is 256 MB, right? In traditional systems, size of each block is only 4 KB. Only 4 KB. Size of each block is only 4 KB. But in Hadoop, it's a yes 128 MB. Default is 128. 128 is very big size, right? So why this very big size? Because of big data handling. Big data handling, big size required. Hadoop designed for high throughput. High throughput means at a time delivering data. So at a time delivering huge amount of data is the high throughput. High throughput. So high throughput means at a time delivering huge amount of data is high throughput. That is called high throughput. Dumping at a time huge amount of data is a high throughput. High throughput. Okay. Yes. So Hadoop is a high throughput here at a time delivering 128 MB data here. So for example here, see, this is a 1 TB file. 1 TB file transferring. 1 TB file transferring in network. What happens? Transferring network. Yes. Yes, data file transfer network. Yes, also practical this is. In traditional systems, what happens in Hadoop, what happens also practically. Yes, we'll see in map-reduce programming also that. Yes, after finishing this topic, immediately map-reduce programming. That time I'll show that. Yes, suppose 1 TB file transfer network here. 1 TB file transferring the networking. So what happens here? Suppose traditional systems, what happens in traditional systems? So like suppose Linux or Windows. Linux or Windows, what happens? Linux or Windows, what happens here? First, one block transfer, that means 4 KB will transfer. After that, next to 4 KB, next to 4 KB, one block transferring at a time here, 4 KB, next to 4 KB, so next to 4 KB, so next to 4 KB, 4 KB, 4 KB, 4 KB, like this transfer rate. Yes, how many 4 KBs becomes 1 TB? Many number of times, right? Yes, suppose same thing Is Dfs in Hadoop distributed file system, what happens here? 128 MB will transfer at a time here. 128 MB, next 128 MB, so next 128, at a time 128 MB will transfer. At a time 128 MB transfer, right? Like this. So 128, 128, 128, 128 like this. So at a time 128, 128, 128 means high amount of huge amount of delivering at a time, right? Okay. So 1 TB file transfer network. So Linux means 4 KB, 4 KB, 4 KB transfer. But here Hadoop whatever 120 at a time delivering 128 MB. So next delivering 120 MB. So within short time this will transfer, right? Okay. So for that reason, block size more here. Okay, block size high throughput. Hadoop designed for the high throughput to give high throughput. Okay. Yes, performance. Yeah, we'll discuss that performance also. That everything considering here. Okay, so 128 MB. Yes, maybe heavy load. Heavy load, maybe performance decrease. We'll discuss wait. Topic is there. Yes, that is comes on data processing. In data processing, we'll discuss that. Wait, it's a data processing topic. So next coming topic. So 128, 128, right? This is. So this is size of each block. What is size of each? Yes, it's an entry question. What is size of each block in Hadoop? Yes, 1.1.x version 64 MB default, 2.x version is 128 MB. So what is size of each block in Hadoop here? So 64 MB, next 128. Your answers like this. Okay, so this is size of each block. Now what happens in Hadoop? Come to this here. Your file divides into multiple blocks and distributing into multiple nodes in cluster, right? So this is about block. So this is about block. Okay, fine. Now, yes. Now loading, for example, here data loading. Yes, 100 GS loading file with 100 GB data. What happens here? Okay. Yes, 100 GB file loading here. What happens? Okay. So 100 GB data file loading into cluster. File loading into cluster. What happens here? 100 GB data file loading to cluster. So first request goes to name node. Simply that request goes to name node. Okay. Every data loading request simply goes to name node. Name node taking that request. Okay. So yes, 100 GB data loading to the cluster. Okay. So first of all, request goes to name node. So every request goes to name node, right? The request goes to name node. Okay. So request goes to name node. Yes, on receiving request, what happens here? So every request, yes, simply every request goes to name node. Yes, maybe data loading request or job submission request. Every request simply goes to name node. Okay. Yes, on receiving request, what happens here? On receiving, yes, on receiving request, yes, name node, split the file, split the data, name node, split the data into multiple blocks, data into blocks, splitting into blocks. First of all, splitting into blocks, splitting into blocks, right? Yes, what's happening? Splitting into blocks. Yes. So on receiving request, name node, split the data into blocks. Now 100 GB equal to how many blocks? Let us calculate. 100 GB equal to how many blocks? That is question here. Yes, 100 GB is equal to how many blocks? Yes, size of each block is equal to, yes, size of each block is equal to 128 MB. Let us say consider second version of Hadoop because we are working on second version. Okay, size of each block is equal to size of each block is equal to, yes, size of each block is equal to 128 MB. Okay, so 1.x. So this is 2.x version, right? 2.x. Suppose if it is 1, yes, right, 800, correct, 100%. 1.x version. So 1.x version, size of each block is 64 MB. That case, what is size? 64 MB, 128. Okay, yes. Now 100 GB, yes, 100 GB. Yes, let us take 1 GB here. 1 GB equal to how many blocks? 1 GB means 1024. 1 GB means 1024 MB, right? 1024 MB. 1 GB is equal to 1024 MB, right? So 1024 divided by 64 MB is equal to how much? 64 MB means is a, yes sir, 16 blocks. It's a 16 blocks. Just 16 blocks, right? 1 GB is equal to, yes, 1024 MB divided by 64 MB is equal to 16 blocks, right? 1 GB data equal to 16 blocks. Okay, 1 GB data equal to 16 blocks here. Suppose 100 GB data, how many blocks? It is 1600, obviously. Okay, 1600 blocks. So 1 GB data is a 16 blocks. Then 100 GB data is a 1600 blocks. So the case of 1.x version, right? 1.x version. Suppose second version of Hadoop. So case of 1.x. Next 2.x version. Yes, if it is 2.x version, yes, 1 GB, yes, is equal to, so 1 GB data. 1 second. In second version of Hadoop, so this is 128 MB, right? It's a 128 MB. So this how many here? 8 blocks. 8 blocks here. So this is 100 GB is equal to how much? 800 blocks. So simple calculation. 800 blocks, right? Let us say second version of Hadoop. What happens here? 800 blocks. Now here first 100 GB data. So 100 GB file with 100 GB data loading. Now 1 second. This is cluster, okay. Now let me take the cluster. This is cluster. Yes, now data loading request, not job submission. Job submission later. Data loading. So 100 GB data loading. Now 100 GB data loading. Now this request goes to name node. On receiving this 100 GB here, now name node divides into 800 blocks. 800 blocks, right? Then distributing onto multiple nodes in cluster. 800 blocks just distributing onto multiple nodes in cluster. Suppose here 100 block space available. So 100 blocks here. First 100. Okay. Suppose suppose no space here, no space available. Suppose here second one no space, no space. Next go third node. Suppose third node 50 blocks available. Next here, suppose next 200 blocks available here, right? Suppose next 100 blocks available here like this. Next here 150 available, 150 like this. Distributing onto multiple nodes depends on space availability. One more thing here Hadoop following some algorithm distribution. Yes, there is an algorithm for the distributing data. Yes, that algorithm I'll tell you. Just wait. What is algorithm following? What we will discuss. So here, so 100 blocks, 50 blocks, 200 blocks, 100, 150. Next maybe 70, maybe 80. Depends on space availability. Distributing onto multiple nodes in cluster. Okay. Okay, distributed. Fine. File distributing into multiple nodes in cluster. Distributed, done. Distribution is done. Next file, second distribution. Yes, suppose next file getting, for example here, yes, requirement is yes loading data, yes loading historical data. Let us say loading historical data. Requirement is loading historical data. Loading historical data. Right, okay. Suppose 2010 years data loaded. 2011 years. 1 second. Suppose in data nodes. Suppose each node capacity is 100 TB, 100 TB, 100 TB, 100 TB, 100 TB, 100 TB like this. All the 100 like this. 100 TB capacity. Each node is 100 TB capacity. That is max. But that is 100 TB is not recommended here. Just only 50 TB max. 48 TB that is recommended. 48 like this. Like this all 48 like this. So there are 100 nodes. 100 nodes here. Okay, every file yes will distribute onto multiple nodes in cluster. Suppose 1 second, for example here first node, in this suppose in first node 200 GB free space available. Assume that there is 200 yes GB free space available. 200 GB free space available. Assume that 200 GB free space available in first node, but what's the file size? Only 100 GB. So this all the 100 GB can be stored into single nodes, but Hadoop won't follow like this. Reason, loss of processing power. That topic we'll discuss next. Just wait. In processing, yes, in data processing, I'll explain that. Okay, 100 GB data we are distributing onto multiple nodes in cluster. Suppose getting 10 GB data, even 10 GB data also distributing onto multiple nodes cluster here. Even 10 GB data. Okay, suppose sometimes getting 1 GB data, even 1 GB data also divides into multiple nodes in cluster here. Never storing at single node here. Okay, suppose 10 GB data, but 200 space available here. First node itself is having 200 GB free space, but what is size of that is only 10 GB. That means this all the 10 GB data can be stored into one node, right? Can be stored. Okay, because the space is available, but it won't store. Reason, loss of processing power. Yes, we'll discuss. Wait, what is loss of processing power? Next topic we'll discuss. So always it will try to distribute onto multiple nodes in cluster. Maybe 100 GB data. Yes, slow processing. I will tell you. Just wait. What is that processing power? We'll discuss. Wait. 100 GB data. That data will be 100 GB data or 5 GB data or 10 GB data. Yes, any amount of data. Always it will try to distribute on multiple nodes in cluster. What is advantage of distributing in multiple nodes in cluster? We'll discuss next topic, that is. Okay, not distributing like this. Suppose 2010 year data loaded. Now currently this cluster capacity is 100 nodes. Current capacity 100 nodes. Current capacity, let us say 100 nodes. So 2010 year data loaded. 2011 year data loaded. So 2012 year data loaded. 2013 year data loaded. Of loading 2013 years, 4 years of data, not cluster field. Cluster field, yes, requirement is 2010 to yes 2020 up to the 2014, yes 2015, yes 2016, yes 2017, okay 2018, yes 2019, 2020. Yes, I want to load this much of years of data. Yes, up to 2013 data loaded. Of loading this data, cluster field. That 100 nodes cluster field. Node is nothing but computer. Node means is a computer. 100 computers using 100 computers for storage purpose. Yes, data loading request taken by name nodes and distributing and multiple nodes, storing and multiple nodes in cluster, multiple computers, right? Suppose of loading 4 years of data, that 100 nodes are filled. 100 nodes are filled, right? Now still data. Still how many years? 7 years of data, right? Still 7 years of data. That means that incoming data is more than the capacity of this cluster, right? Cluster capacity only 100 nodes. 100 nodes available. All 100 nodes are filled. Still data is there. Now cluster facing big data problem. Okay, data is more than yes data. No space is filled with this only 4 years of data. Still data 7 years of data. This 7 years of data has loaded cluster. Now cluster facing big data problem. Now this is called as big data. That historical data. So what are data we are loading here? That data is more than the capacity of cluster. Means it is called as big data. This is meaning of big data here. So big data, any amount of data which is beyond of storage limit, that is called as big data. Now data. Now this 10 years of data is more than the capacity of cluster. Right? Now it's facing big data problem. Now this is called as big data. Right? Okay, facing big data problem. Now what is solution for this? For this, what is solution? Yes, for this here. Now there are 100 nodes, right? Without disturbing existing cluster, now admin can add some more nodes. Admin can add some more nodes. Okay, admin can add some more nodes. Yes, admin can add some more nodes. Okay, yes, by simply making some administration, okay, configurations without disturbing existing cluster, admin can add some more nodes. Let us say 5 nodes. Adding 5 nodes. 100 nodes plus now 5 nodes added, right? Now again loading data. Again loading data, right? Yes, again these 5 nodes also filled. Yes, you can add next 5 nodes. Adding next 5. Suppose this also filled. Yes, next 5. You can add next 5. Next 5. Next 5. Okay, right? Yes, still yes. Again fills. Again next 5. Next 5. Continuously you can add it here. Continuously here. So these 5 also filled. These 5 also filled. Now you can add next 5 more nodes. Okay. So next 5 more. Next continuously can add. Without disturbing existing cluster, you can add nodes continuously. Okay. So this extension, right? So this is adding nodes. Adding 5 nodes, next 5, next 5, next 5, next 5 like this. Adding nodes continuously. Right? Yeah, this concept is called as horizontal scaling. This is called as horizontal scaling. This is called as horizontal scaling. Horizontal scaling. Vertical scaling, horizontal scaling. What is the difference here? In vertical scaling, what happens here? Just increasing capacity of disk, just the volume of server, just increasing volume of server. But in horizontal scaling, what's happening here? Increasing number of servers. Okay, horizontal scaling is a process of increasing number of servers. Number of servers increasing, right? Yes, if it is increasing volume of server, that is called vertical scaling. Vertical scaling is a process of increasing volume of server. What is horizontal? It's a increasing number of servers. If increasing number of servers called as horizontal scaling. So Hadoop follows horizontal scaling. Increasing number of servers. Just it's a increasing. Just increasing. Yes, increasing number of servers. Increasing number of servers. This is horizontal scaling. Number of servers. Just increasing number of servers, right? Then maximum how many nodes? How many nodes? Maximum how many nodes can be configured? Can be configured in a cluster? Can be configured in a cluster? Now question here like this. right? Okay, so like this, adding nodes, initially 100, 5 nodes, 5 nodes, 5 nodes, 5 nodes, 5 nodes, like this. How many like this? So maximum how many nodes can be configured in a cluster? In a cluster, okay, how many nodes in a cluster is equal to this value equal to, yes, how many nodes in a cluster? This value is equal to 10,000 nodes. In 1.x version, say 1.x version is 4,000 nodes. See 1.x version, in 1.x version this value is 4,000 nodes, just only 4,000. Okay, as for 2.x and 3.x version, these three cases, okay, yes, 2.x and 3.x same almost, story is same here, but some features are different. Okay, so 10,000 nodes, right? 10,000 nodes. Okay, so we can configure up to 10,000 nodes. Okay, 10,000 nodes. 1 second, someone asking question. Yes, in all those cases, one master node will, yeah, one master node, yes, only one master node. Okay, for all 10,000 nodes, only one name node, only one name node for all 10,000 nodes. One master is enough. Okay, yes, I was involved in 4 clusters. Yes, we have configured 4 clusters. Okay, very big clusters we have configured. Okay, our first cluster, yes, is a 400, around 400 nodes cluster, first cluster. Second cluster is around 650 nodes. Third cluster is small cluster, just 150 nodes because of less amount of data. Okay, next fourth cluster around 350 nodes. Okay, I'll tell you how to configure that cluster and all that environment. I'll tell you. I have practical experience. I'll show practically. Okay, so 1,000 nodes, right? So here maximum how many nodes can be configured in cluster? 10,000 nodes. Suppose all 10,000 nodes failed. Still data is there. Suppose here, yes, loading data continuously. Yes, 2013, 2014, 15, 16. Suppose of loading 2016 cluster filled. Still data is there. Still data is there. Then going for one more cluster. Second cluster. Okay. So once cluster filled. Yes, once cluster. So once cluster filled. Yes, once cluster filled. Yes, we can configure one more cluster. We can configure. So configure one more cluster. One more cluster with 10,000 nodes. With 10,000 nodes. With 10,000 nodes. Right? Okay. Now questioning here, where keeping all the 10,000 nodes? Where cluster placing here? So let us see data center. Let me show our company data center, default data center. Our client, one of our clients data center. Hadoop material. Yes, I think I already shared the documents for some guys shared. This one. So these are documents. Yes, in this main document, whatever we are discussing, it's there in main document. See yesterday topic. Yesterday topic, what is big data definition? Any amount of data which is beyond of storage capacity called as big data. Okay. Yes, big data means really it's a big one. Okay, large data sets. Okay. See 1 byte equal 8 bits. Yesterday topic 1 KB, 1 MB, 1 GB, 1 terabyte, petabyte, exabyte, zettabyte. Yesterday data. Yesterday topic. This is next. Historical data, black box data, social media data. What comes on the big data? See yesterday topic. This all the yesterday topic. Okay, that examples. Okay, now today topic is big data challenges, data storage, data processing. Now our topic is this data storage. Okay, see data the storage, data process, these two time taken, but remaining all four within 1 day finishing. Okay, yes, today topic is data storage. Okay, fine. Yeah, we'll share the document. Don't worry. We'll share the documents. Okay, yes. So once the cluster filled, we can configure one more cluster with 1,000 nodes. Data center is like this. So this is see. Now we are discussing this solution: centralized system, user centralized system, community hardware is Google solution. This is now this is our topic. Okay. Yes, this is data center. Data center. Rack 1, rack 2, rack 3, in racks placing all systems. Okay. Yes, nodes are physical computers. Physical like our computer, like our desktop, like our desktop. All node is nothing but a computer. Our desktop only. Okay. So this is data center. In this, keeping all the CPUs. Okay. Keeping all the CPUs. See here, this is in this, see this node is nothing but this kind of hard disk. This node can, every node can hard disk, RAM, motherboard, okay, processor, everything here. The complete CPU, whatever our desktop, same desktop. Nodes are nothing but our desk, like a desktop, like a desktop. So this is computer, one computer with hard disk, okay, hard disk, RAM, memory, motherboard, Linux installation here. This also is Linux based. Here are Linux based. Yes, on every machine there is Linux based. On top of Linux based, Hadoop will be running here. Hadoop will be running. Yes, we'll see practically. All of these things we'll see practically. Okay, right? So node is nothing but just like our computer. It's a physical computer. It's not a virtual. It's a physical one. Physically keeping all the computers in the racks. Okay. Yes, once cluster field here, we can configure one cluster. Then like this, suppose second cluster is a field. Then how many? Yes, maximum number of clusters. Maximum number of clusters. Clusters that can be configured. That can be configured. Configured is equal to 17 clusters. We can configure 17 clusters. So maximum number of clusters that can be configured is equal to, yes, all nodes contains Linux base. Compressor Linux. First step is Linux you have to install. On every computer you have to install Linux. After installing Linux base here, next installing Hadoop. See, on all the computers we should install Linux here. After installing Linux, on top of this we have to install Hadoop. After installing Hadoop, next we have to bring in the cluster. First install Linux, next install Hadoop. After installing Hadoop, you have to bring in the cluster. Okay. Yes, number of how to question is how do we decide limitation on number of clusters? First of all, number of computers. First of all, how many nodes are required? That depends on data. Depends on data. How much volume of data? So how depends on volume of data generating. Yes, that I will tell you. Yes, at the end to end in project explanation is there. I'll tell you. Yes, right from the cluster configuration to, yes, project implementation. Yes, all that life cycle, complete life cycle environment I will explain. End to end life cycle topic is there. That time we'll discuss. Okay, so maximum number of clusters that can be configured to 17. Okay, suppose 17 clusters complete means your data center is over. Data center filled, big data center filled. Yes, still data is there. We should go for one more data, second data center, next data center, next data center. For example, Amazon have the many data, hundreds of data centers. They have around 100 data centers worldwide. Okay, they are planning for 3 data centers in Hyderabad. Many data centers. And Amazon is having many data centers. Okay, Facebook is having many data centers, right? Okay, even Facebook are planning to move to Hyderabad for data centers. Okay, yes, data centers. Right, okay. Like this, increasing data centers. One data center filled, hiring one more building, next data center, next building. Data center is not like our double bedroom flat, not like a triple bedroom flat. It's very like a warehouse, very building this, very huge building. Looks like a village. Looks like a village. Okay, the deep world data center looks like a village, somewhat like a very big village. Okay, to walk through data center it will take at least 1 day. Complete data center, to walk through complete data center it will take one day minimum. Yes, watching each and every computer, inspecting each and every rack, it will be taken for 1 day. Inspecting racks only taking for 1 day. Suppose each and every computer inspecting is maybe taking for 10 days. Very big one that is. Okay. Yes, 1 second. Are there any form which are going to for big data on cloud to every company is maintaining their own data? Yeah, most of the companies are maintaining own data. Okay, some companies are depending on cloud. Yes, what is cloud? Cloud is nothing but it's just they are hiring space. Cloud they are hiring space. Suppose you have the company, your company, yes, you can store get a cloud environment. Cloud is a company. They are hiring space. You can take the space. That space for Windows OS or Linux space. You can choose your operating system, how much space you want. You can choose. Then you can store your data. Yeah, that I'll show. Yes, AWS topic is there. In AWS, how to choose your instance. How to choose instance. Okay. How to choose the instance. Next, how much storage space required. What is hardware configuration. Everything we'll see. Okay. Yeah, we can configure in Hadoop in cloud. Yes, that is EMR instance. We'll discuss. I'll explain. Okay, I'll explain. Topic is there. How do they run data center in summer? No, Hyderabad somewhat cool compared to any other. Yes, any other cities. Hyderabad, Bangalore, Hyderabad, both are cool places. Okay, compared to any other location in India. Hyderabad mainly pollution free compared to any other city. Hyderabad is a pollution free. Next, well organized. Hyderabad is well organized compared to anyone. Okay, well organized place. See, Pune pollution, complete pollution. Pune all mechanical industries, completely polluted. But Hyderabad is no pollution. Okay, without any pollution here. Next, it's a well organized city. Traffic system, well controlled traffic system. Once upon a time, traffic is very full of traffic. Now traffic reduced because of metro and all these many facilities, because of ORR and those things. Yes, Hyderabad has become very cool in traffic too. Okay, it's very, yes, it's organized one. Okay, even government also very organized government. Okay, now current government is, yes, very organized. That minister, IT minister KTR is very organized manner. Is very good, excellent guy. That guy is a very organized. He's very hard worker. Okay, because of him, yes, now becoming popular. This is Hyderabad. Yes, so more number of clusters. Yes, max number of clusters can be configured up to 17. Like this, continuously data centers. Okay, setting continuously data centers like this. Okay, right. So like this, yes, if number data more number of clusters. So what is happening? There is no limit on data to storage. We can use any number of computers, continuously increasing capacity of cluster. So that problem solved, right? Yes, data storage problem solved. So this is solution for the data storage. First one data storage, right? Data storage. Okay, if data getting added somewhere come without disturbing existing cluster, we can add the nodes continuously. Continuously, you can add the nodes here without disturbing existing cluster. So you can, if cluster fill, you can go for next cluster, next like this. Suppose all clusters fill, then you can go for one more data center, one more, like this many data centers. Right, okay. So this is data storage. So this is solution from the Hadoop. Okay, data storage solution from the Hadoop is like this. Yes, if it is, yeah, traditional this is a limited storage space, right? Limited storage space, limited. Beyond that, we can't store. So this is solution for this. Next, data processing. Yes, let us see data processing here. Yes, in Hadoop, what happens here? In traditional systems, what happens? Traditional systems versus Hadoop here. Okay. Yes, suppose huge amount of data. Traditional system taking a lot of time. Suppose, for example, traditional system taking data processing for 1 hour. For Hadoop, just 5 seconds enough. Traditional system taking 1 hour to process some data. Same data Hadoop can process in 5 seconds. 5 or 2 seconds. How it can process tomorrow we'll discuss. Data processing. This topic again, this I need minimum 1.5 hour topic. Very interesting topic. Data storing, okay, fine. Data processing is very interesting. It's a distributed data processing, parallel processing. Multiple servers will process the data. Tomorrow we'll continue this topic. Very interesting topic. Tomorrow we'll continue that. Okay. Yes. So what all Java concepts are required for MapReduce? We can brush up. Yes. Again, once again, I'm planning to start with Java. So maybe within 2 days I will announce that CoreJava, especially for our Hadoop guys and others. Many are asking to start CoreJava. Parallel, I'll start CoreJava. Don't worry. Right? Okay. Yes. Right. So that's all for today. Tomorrow we'll continue. Yes, I'm saving these documents. I'll forward you. Yes, big data challenges. Big data challenges, our topic. Big data challenges. I'll forward you in your group. Hadoop material. Yes, your batch. 8:45 note, 10:30, 10 a.m. no, 10:30. No, 10 a.m. no, yeah, 10:30. Big data challenges. I'll send. This is. Yes, any new members? Yes, give me your WhatsApp. WhatsApp. Just WhatsApp me what details. My WhatsApp number. Yes, 8179-189-123. Okay. Yes, your name. Next, what's the course you are attending? Okay, next. What's your time? Just send me these details. I will add to that group. Just I will add to that group here. Okay. Yeah, thank you. Yes, every session will be like this only here. Yes, excellent. I will explain very excellent, no doubt. Very interesting. Every session will be interesting, no doubt. Okay. Very clearly, each and every topic. Very yes. Once you go to practical session, you can feel very happy. Okay. Yes, that is experience. Okay. Suppose learning somewhere and teaching somewhere means yes, may not be explained like this. It's my experience. I'm explaining. That's it here. I'm not doing anything. Just experience. Explaining. That's it here. Okay. Yes, I'll share the material. So don't worry. Yes, your match 9 a.m. Yes. Just go through that today topic. I'm sharing today topic. Yes. 1 second. 10:30 a.m. Big data challenges. Just go through that. Okay. Yes. Everything I'm sharing here. Sorry. Not for your batch. It's not for your batch. One for 9 a.m. Yeah, Hadoop 10 a.m. Yes, I have to share here. Just done. Just go through this. Yeah, that's what. Yeah, I shared to Linux group. Okay, just go through that. Yeah, thank you. So we'll see tomorrow.